we have a block which is on a frictionless surface, and onto the block there is a body. It could be a sphere, it could be a cylinder, it could be anything which can roll. Over here force F is applied, and there is sufficient friction between these two so that there is no slippage. So in this question we are interested in writing the equations of linear mechanics as well as rotational mechanics. If we draw the force diagram, so obviously there is a block M. When this is pushed this way, this is going to have some acceleration, and this will rotate in this direction. With respect to this will move in the backward direction. If we talk about the motion of linear motion of this, let's say sphere, with respect to this, then certainly when this goes in this direction, this with respect to this will move in the backward direction. Whereas if we see from a person who is on the ground, the acceleration of this will be also in this direction, and the acceleration of this will also be in this direction, but acceleration of this will be more in this direction, acceleration of this will be less in this direction. That's why with respect to this will seem to be accelerating in the backward direction, but with respect to a person on the ground, both of these, they are accelerating in this direction. Acceleration this is greater than the acceleration this. So let's say this acceleration is A1 and acceleration of this center of mass is A2. When you draw the force diagram, so over here, so we say this is going with A2 and this is going with A1. Let's say its radius is R. Let's say this radius is R, right? Interlockings, they are like this. So this applies a force in this direction, friction force. This applies a force in this direction. We are not talking about the limiting value of friction force. Let's say the force is acting like this. Now we are interested in writing the equations for this as well as this. Equation for this, simple. Over here the force F is being applied. So F minus this friction force is equal to M into A1, right? Linear equation for this for linear mechanics, this with the force is F only. F is equal to M into A2. Force is equal to mass into action. The force which is being applied over here is F, and masses of this is, we have taken it as small m, into A2 is the acceleration of center of mass, so F is equal to M into A2. Now because this is rotated this way, there is going to be some alpha, so it means there is going to be some torque. Torque is what? If we take the torque about O. So F is this way, F is this, R is this, so this will rotate this way. That's what we observe, that this alpha will be in this direction. So torque about O we have to find out, and we'll put it equal to I alpha. Torque is F into R. So torque is force, that is friction force, into perpendicular distance between line of force and axis of rotation, that is R only, is equal to I about I. If this is sphere, solid sphere, you can put it as 2 by 5 mr square. If this is hollow sphere, you can put it at 2 by 3 mr square. If this is a disk, you can put it as mr square by 2. So let's write it as I only, I into alpha, right? So this is equation number 1, this is equation number 2, this is equation number 3. Now one more equation we can have is, that is the relationship between the linear acceleration, that is tangential acceleration, and the angular acceleration. What is the relationship? A is equal to R alpha. Now this person on the ground sees that this block is going with the acceleration A1, and this is not slipping with respect to this. So means acceleration, absolute acceleration of this point is also A1, and absolute acceleration of this is A2, and A1 is bigger than A2. So A1 acceleration is more than A2 acceleration, that's why it moves in this direction. So when we apply A is equal to R alpha, so it means F into R is equal to I into alpha. Alpha is A is equal to R alpha. A is the acceleration of this with respect to this, or this with respect to this. So this is absolute acceleration is A1, its absolute acceleration is A2. So A acceleration is going to be A1 minus A2 is equal to R into alpha. That is, alpha is going to be A1 minus A2 upon R. So we have these 4 equations. From these 4 equations, we can find whatsoever has been asked for. If it is asked, that is what is the maximum value of the force which can be applied, then we know that is the friction force will go to its limiting value, that is mu into n, that is mu mg, that will the limiting value of friction force, and we know the value of this, and accordingly then we can find the value of A1 and A2 we can easily find.